Hi students, welcome to the second video. Before you watch this video, you must watch the video before, which was table of sine first degree f of x equal ax plus b. Now we're going to continue if you have second degree. Second degree, it means graphically it's a parabola. You all know a parabola. We have three cases for second degree. Case one, if you have two distinct roots, delta is positive. So in this case, it means that the parabola, as you know from before, cut the x-axis in 2 points. If a is negative, you have that form. If a is positive, you have a maximum. You have that form, and you have here two roots. As you can see, if a is positive, you can see here the part above the x-axis, it's f of x, y is positive. Then we have the root, which is called a 0. If you replace the root in the equation, it will be here 0. Then minus, then 0, then plus. So as you can see, it means if a is positive and you have two roots, first of all, same sign as a, opposite sign of a, and then same sign of a. And similarly, if a is negative, it starts by same sign as a, negative, then the root, which is 0, then positive, opposite sign of a, since here a is negative, then 0, then same sign as a. So from now and on, we're not going to graph and to do all of that. You need to know that if you have second degree and you have two distinct roots, you look at a coefficient of x squared, you start same sign as a, then opposite sign of a between the two roots, then same sign as a. So let us take example. Suppose here I want to find the sign of this f of x to be bigger or equal to 0. So I have two polynomial. So I find the root of the first of the two. The first one is degree 1, like we did in the first video. If you equate it to 0, you have root 2. The second one is second degree. You can do delta b square minus 4ac. Or if calculator is allowed, you can use it directly from calculator or using the product and sum here because it's simple. One of the root is 1 and the other one is 2.5. So we do the table of sign like we did in the first video. X minus 2, the root is 2. As we said in degree 1, opposite sign, same sign. So since the coefficient of x here is positive, so opposite, when you reach 0, it will be same sign, which is positive. Here it's an equation of second degree. I have two roots, 1 and 2.5. So I put a circle here. It means that if you replace x by 2 here, this is 0, or by 2.5. Since it's an equation of second degree and you have two roots, as we said above, same sign as a, opposite sign, same sign as a. Since coefficient of x squared here is positive, same sign, it will be plus, then negative, between the roots, opposite sign of a, then positive. So here we do the product because I have a product. So minus, plus, minus, and then plus. So here this whole one is 0 since I don't have denominator. If x is 2, everything will be 0. If x is 1, here is 0. 0 times, for example, if replaced by 1 minus 1 is 0. If replaced by 2.5, you're going to get 0.5 times 0 is 0. So that's why we put circles on all the roots that we have. Now, if I want, what do we need? You want bigger or equal to 0. So here and here. So from here till here and from 2.5 till infinity. But since I have equal, so I take the boundaries. So I say x belong from 1 till 2 close, union from 2.5 close also because I can take the boundaries till infinity, and infinity we cannot close infinity because we cannot reach infinity, always open. Suppose now I want to graph it graphically. I have a root at 1. Let me put here the root at 1. I have a root at 2 and I have a root at 2.5. Before the 1, the curve is down, so it's down. Okay, then between 1 and 2 it's up, and from 2 till 2.5, from 2 till 2.5 it's down. Then at 2.5 it's a root, as you can see here. Then it goes up till infinity. Now if you want to have a perfect graph, you must replace, for example, you need to graph it using Geogebra, because it's in grade 12 you're going to learn how to graph parabola, functions, polynomials, and rational and irrational functions. So, but now we can graph it, we can approximate the graph, no need to be, for example, accurate. And if you want to check your work, you can go to Geogebra, for example. Let us see Geogebra. To teach you how to graph it, you can put, for example, here f of x equal x minus 2 into 2x squared plus 3x plus 3x minus 5. So this is the curve. This is the accurate curve. As you can see, it's similar up to a certain point to the curve we have it. So before the minus 1, you have here, for example, if you want to check that this root is minus 1, so here you can put it. So you have at minus 2.5. Here, as we said, we have at 1, and here, as we said, we have at 2. So it's similar to the one we graphed, but it's more in the maximum here. It's not similar to that one, but here we are approximating. As we said, to know how to graph it accurately, we're going to do it in grade 12. So now let us continue. This is another example. I have an equation of second degree and degree 1. Here the roots, you can check it. If you do delta or calculator, you have these two roots. And this one, if you equate it to 0, you have a 3. So let us start by doing the table of sign. We put it from minus 2, then you have 1.5, then 3 in increasing order. The first one is an equation of second degree. I have two roots, minus 2 and 1.5. Always in the equation of second degree, if you have two roots, we start by same sign as A, opposite sign, same sign. A here, coefficient of x squared is negative, so same sign is minus. Here it will be positive. Then after 0, all is minus. And the second one is second degree 1. Degree 1, you can, as we did in the first video, it's opposite sign of A. Here, coefficient of xa is minus, so opposite sign, so it will be plus, 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 then minus. And the product here, you have the zeros on the 3. Minus times the plus is minus, so here a plus, here minus, and here a plus. What I want less than 0. Less than 0, it's here and here. Because I don't have equal, we don't have equal, so we don't take the boundaries, always open. So from minus infinity till minus 2, we open it, we don't close it. Union from 1.5 till 3. So always open. So if I want to graph it, I take minus 2, and then I take 1.5, which are the roots, and the 3. Before minus 2, it's down. So you can graph down. Between minus 2 and 1.5, it must be above, goes up. Then between 1.5 and 3, it's down. Then it goes to 3, which is the roots here, the 3, and then it continues up. Okay, so it has that shape. We're graphing a shape. What I want here less than 0, so I need that part, and that part. Above, I forgot to tell you, we need here positive. Positive, it will be this part here. So from here, I want that part here, and that part here also, because I want the above part, above the x-axis. So that part and that part here. Another example, in this example, I took denominator, as we did in the first video. So here, first of all, I have equation of second degree up, second degree here, and degree 1. I start by numerator, the roots. I have two roots, 3 and minus 3.5. You can check it using your calculator. Here, for this one, second degree, no need to use the calculator, because if you equate it, minus x squared equal minus 4, so you have plus or minus 2. And x minus 1, the root here is 1. So we put all the roots from the lowest to the biggest. So the lowest is minus 3.5, then you have the minus 2, then you have the, sorry, here you have with the 1, then you have the 2, then the last one is 3.5. So we start. The first second degree, you have two roots, 3 and 3.5. Here I have something wrong. Let me correct it. I have 1, 2, 3, 4, 5. Something is missing. So here it's a 3, not sorry. Here it is minus 3.5. So here it's a 3, not 3.5. Sorry for that mistake. So let me start by the first one. You have two roots. You have the 3 here, and you have minus 3.5. So since equation of second degree, same sign, positive, then negative, 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 then positive. The second one, you have minus 2 and 2, which is also in denominator. We're going to talk about it. So come in second degree, also second degree, coefficient of x squared is negative. So minus, minus, then plus, opposite sign. When you reach again 0, it will be minus. The third one, it's degree 1, like we did in the first video. Opposite, then same. A is positive, so minus, 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 plus, plus, then same. So at the end, what do we get? Because here product and division, minus times minus is positive. Minus times minus times minus, minus. Double minus is a plus. Minus times a plus times a plus is minus. Minus times a plus is a plus. And plus times minus times a plus is minus. 0 over a number is 0. So at 3 and minus 3.5, it can be 0. But since we cannot divide it by 0, as I said in the first video, so we have a vertical asymptote at minus 2. So it's impossible. So it's a vertical asymptote at minus 2 and 2. A vertical asymptote, you're going to learn it in details in grade 12 in calculus, or grade 11 at the end of grade 11. And you have impossible also at 1. So these are the vertical asymptotes. So I have vertical asymptote at minus 2. I have a vertical asymptote at 2, and I have a vertical asymptote at 1, minus 2 and 2. This is minus 2, this is 2, and this is what? And also at 1. Concerning the roots, I have a root at minus 3.5 here, and I have a root at 3. So let us start the graphing. Start the graphing, first of all, it's coming from up, going to 0, touching 0. At minus 3.5, then going down negative till minus 2, and minus 2 here is a vertical asymptote. It will become near the curve, but it will not touch it because this is asymptote. We cannot take value minus 2, because if you divide minus 2, it's minus infinity here, it goes down. Then after the minus 2 to that side, it comes from positive, from up. But how? Also we have a vertical asymptote here, as we said, so it must be asymptote from up. Then going where asymptote to 1. We have asymptote from minus 1 till 1, but always it's up. We cannot go down. So here you have asymptote coming. You have somewhere here a minimum. We can put it anywhere you want now for in this section. Then it goes also at 1. How? Vertical asymptote at positive. Vertical asymptote is positive. It's up, not down. From the other side, from 1 to the right of 1, you have negative asymptote from that side at 1. Then it goes asymptote to 2. So here it's always minus, but here you have as if you have like this. From 1 till 2 down, all is asymptote. So here it's asymptote. It will not touch it. You have a maximum. You can put it anywhere you want. You can put it here. But what concerns me, I want asymptote from that side and asymptote from that side. Then to the right of the 2, it comes from up. It's positive. Asymptote from up, it will become near the, it will touch the root, which is here, the 3, and then it continue down. So you can check your curve more by using Geogebra. You can put these and you can check. What I want is bigger than 0, so this part is included, this part is accepted, and this part is included as we wrote. So what will be x in that case? Bigger or equal to 0, from here to here, from here to here, and from here to here. So I say from minus infinity till I have it minus 3.5. Here it is a close, since I have equal union. I have from -2 open because it's vertical asymptote. I cannot close it as asymptote. From -2 till 1 open because it makes denominator 0. I cannot close it. Then I have from 2 till 3, and at 3 I close it because it's in numerator. It can be 0. Here I have 0. Okay, so here, as we said, here I gave you 3 examples for delta bigger than 0. Let us start now examples when, first of all, case 2, when delta is less than 0. Delta is less than 0, it means I don't have roots. What does it mean? The curve will not cut the x-axis. So it will not cut the x-axis, so it's either always above or always below. As you can see, if a is positive, so it has a minimum like this one. It cannot cut the x-axis. It's always what? The curve, the elevation f of x, it's always positive. So as you can see, if delta is negative, if a is positive, always is a plus. If a is negative, you have a maximum, it's always minus. So that's why we say if delta less than 0, I don't have roots, always same sign as a. Either always positive if a is positive, or all negative if a is negative. And I'm going to take with it the case 3 because it's similar to the one above. If delta is 0, what does it mean? I have one point of intersection. One point of intersection, equation of second degree, it means it's tangent to the curve. Tangent at that point. So since 0 is neither positive nor negative, so we're going to exclude it. But if a is positive, always a plus. If a negative, always negative, except at the tangent point of tangency, where it is what? Which is 0. It's neither positive nor negative. So that's why we put the table, we put minus b over 2a. It's either always a plus if a positive, and always minus if a is negative. Don't do the mistake, because some students sometimes they put it delta 0 minus b over 2a, they put plus or minus. We don't have plus then minus or minus plus in equation of second degree. In equation of second degree, either all is positive or all is negative, with an exception of having a root. For example, this root when delta is 0, always plus or always minus, or you have part positive, part negative, when you have two roots, plus minus plus or minus plus minus. So I don't have the case when we have minus 0 plus or plus 0 minus. We don't have that in equation of second degree. So now let us take an example of the examples here. I have 3 roots. I want bigger or equal to 0. So if you find the root of the first one, I have 2 roots, delta here positive. If you do here delta is negative b squared minus 4ac, you don't have roots. Then so write delta less than 0 not to do a mistake. If you do that one, you have double root, delta is 0, you have a double root. So we're going to start, we're going to put it in increasing form, 0.5, 1, and 3. So the first one, I have 2 roots. I have 1 and 0.5. As we said, if because second degree and delta is positive, same sign as a is 2 positive here. So plus, minus, then all plus. For the second one, delta negative, you look at coefficient of x squared. Here, coefficient of x squared is 1, and 1 is positive, so all positive, everywhere positive. And the third one, delta is 0. The root is a 3 double root. And also, we don't have plus, minus, or minus, plus, as we said. Be careful. Here, delta is 0. You look also at a. Here, a is 1. So, all plus, right and left of the root. So, this is a product. I don't have vertical asymptote because I don't have denominator. So, 3 pluses, product is a plus. Here, minus and double plus, it's a plus. So, I have here a 0. Here is 0, here is 0. But don't forget, I have a double root. So the curve is tangent at the point 3. So here it's tangency. Not to do a mistake, put this arrow to say here I have a tangent. So tangent, it means it comes from up till up or from down till down. We're going to see. I have a root at 0.5. I have a root at 1 and tangent at the point 3. Let me start. Before 0.5, the curve is coming from up. Then it reached 0.5. Suppose this is the 0.5. then it continue down, then it go down, then at 1 it goes up, then up, then it goes back to 3, but 3 is tangency, then it continue, as you can see, to the left of 3 and to the right of 3 it's also positive, it continue up. So here I have a point of tangency, and if I want here bigger or equal to 0, this will be the part, this part also till the end. Okay, if I want to write the interval, I say I want positive. Here it's positive from minus infinity till 0.5. I close it at 0.5. Why? Because I have 0 union. I start from 1 till infinity. Why till infinity? Because this point, which is 3, is included. If this point wasn't included, you have bigger, so you must write from 1 open, you don't have equal, I mean, till 3 open, union 3 open till infinity. Because I have it included, is equal to 0, so I can write it in one interval. So the domain will be from minus infinity till 0.5, this part above, and from 1 till infinity. So let us take more examples. I have prepared another 2 examples where we have denominator. So in this example here, so we start. We have 3 factors, minus x squared. Minus x squared, it means x is 0. It's second degree equation, don't forget, because it's a square, and it's always negative here. Or if you want, delta here is negative, same sign as a, so always what? Negative, but you have root at what? 0. You know that x squared minus x squared is always negative because it's a square. If you take the second one here, delta is negative if you do it, so same sign as a, the second one. A is minus, so all is minus. If a was plus, so all plus. And the third one, here you have delta equal to 0 if you do it. You have double root, so you have root at 1. But because delta is 0, you look at a, all is what? Minus. So here you have minus, triple minus minus, and here minus, because it happens that here all is negative. Here minus x squared always negative. Here delta less than 0, same sign as a, it happens all minus, and here delta equal to 0, all minus. But I have a root at 0. It's possible to be 0 because it's the numerator. Here I don't have roots, and I have here the root at denominator, but since I cannot divide by 0, so at 1 it is what? It is an asymptote. So let me, I want it bigger or equal to 0, so I don't have anything to be bigger or equal to 0, so it's phi, it's empty set. And if I want to graph it, I have the 0, which is a root. I have the 1, which is vertical asymptote. Because here at 0, it's a square, and delta equal to 0, it's a square, so it's tangent. So it goes up, it touches this one, then it goes down again, but x equal to 1 is a vertical asymptote. In the other one, it comes from down, but it cannot go up, so it goes as horizontal somewhere. It can go back. Later on, when we're going to do it in secondary, in the grade 12, you can know about horizontal asymptote. You can take it like this, for example. You can take it as horizontally, or you can take it down, because I'm not the idea here is to know approximate the graph, so we can stop here, but it cannot go out. So as you can see, I want bigger or equal to 0, so I don't have sorry, I want equal to 0, so I take only here by mistake, sorry, I take the point 0. But suppose if you have bigger than 0, so I don't have anything bigger than 0, so only I have one point, which is the 0, because the 0 here at 0, I have 0, it's equal to 0. But if I want bigger, as I said, so it will be empty set. Let us take another example. I want here, I have 4 factors, so I start by finding the roots. The first one, the root is -1. The second one, delta is less than 0, no roots. This one, I have 2 roots. If you do it, I have 1 or 2. And the last one, delta is 0, x is equal to 3. So let me start by the first one. You have the root, which is -1, degree 1. So opposite same, so plus, then minus, 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 minus. The second one, second degree, delta negative. I look at a is positive, so all positive, all positive. The third one, I have two roots. The roots are 1 and 2. Same sign as A because I have delta positive. A is minus, same sign. Then opposite sign, then same sign as A. And the last one, delta equal to 0. The double root is a 3. I look at A, same sign as A. Since A is positive, all is positive. Right and left. Now, the roots of numerators are -1 only. The others are that of denominator 1 and 2 are vertical asymptote undefined, here 1 and 2. And also at 3. 3 is not tangent anymore because even its delta equal to 0 because now it's in denominator. So I have product and division, plus times a plus times a plus is minus. Minus times minus, here it's a plus. Minus times the pluses is minuses. I have 2 minus, product is a plus. Double minus also, it's a plus. What I want less than 0. So from here till here, so from minus infinity, everything here open. Why? Because I don't have equal to 0. I have less, I don't have with it equal. So from minus infinity till -1 open. Union, I have from 1 till 2 also negative. And that's it. So if I want to graph it, approximate the graph, not giving an accurate graph. So I have at -1 here is 0. Here I have at 1, which is a vertical asymptote, 2 is a vertical, and 3 is a vertical. First of all, I have the curve coming from down. Okay, minus, cutting the -1, going up 1, vertical asymptote to 1. Then coming from down, but how? Minus vertical asymptote to 1. Then vertical asymptote to 2, but always minus, so it has that shape. Vertical, it cannot go, it cannot cut the x-axis, so I have a maximum point somewhere, and then going down. And similarly, between 2 and the 3, I have vertical from up, a minimum somewhere, because I cannot, it will not go, always is a plus between 2 and 3, and I have vertical asymptote, it goes up. Then from 3, I have a vertical asymptote, but it will not cut the x-axis. Either it goes to a horizontal asymptote, you can continue like this, or it goes up. So, and what I want is the shape. I'm not going to go into limits and whatever, we're going to take it next year. So that's why this is the curve, the approximation of the curve. I want less than 0, so this part is less than 0 from minus infinity till -1 without the root, and from 1 till 2, as you can see, and that part here above is bigger than 0. I hope that you got the table of sine of second degree, and see you in class.